Hi everyone, and welcome to our very first IT Tech Talk, Get Monitoring Tricks for All Your NICs. We're kicking off a series where we'll focus on different ways to help you make the most of your Splunk instance through short webinars that focus on apps and add-ons, features, best practices, and more. This is part one of two for this month, which we're going to be focusing on our technical add-on for Unix and Linux. My name is Caitlin Reynolds, and I'm a product marketing manager here at Splunk, and I'm joined today by my colleague Robert, who is a consulting sales engineer here. He's going to walk you through today's talk and do a demo at the end. All right, Robert, take it away.
Thanks, Caitlin. Hello, everyone. My name is Robert Gustafson. Welcome to the Splunk IT webinar series. So today I'm going to walk you through the Splunk add-on for Unix and Linux. We're going to cover everything from why you should be collecting this data and problems you can solve with this data, and all the way through wrapping up with a demo of the TA at the end. So today we are here to learn how to collect data from your Unix hosts and act on that data to keep your infrastructure running optimally. At Splunk, we facilitate the data collection from your Linux hosts through the use of the Splunk add-on for Unix and Linux. This TA provides a set of inputs to collect data from various performance statistics, system information, and logs from Unix-based workstations and servers. It also provides a set of Splunk knowledge objects to facilitate searching and reporting of the data. To get started with collecting data from your Linux hosts, you'll need to head over to Splunk Base and download the app. The TA can be found on Splunk Base simply by searching Splunk add-on for Unix and Linux. So why bring in performance statistics, system logs, and configuration data from your Linux host? Bringing the data from your Linux host can help unlock insights from your data in many different ways. Let me now cover a few examples. For years now, infrastructure has become more and more virtualized, whether you're virtualizing on-prem or in the cloud. Either way, under-provisioned hosts can lead to outages, and over-provisioned hosts can cost us money. So collecting and analyzing performance statistics like CPU, network, disk, and memory can help you find the perfect balance of resources to run your business. Oftentimes, changes to your environment are actually opportunities for things to go wrong. Performance statistics can be used to baseline your environment before and after changes are implemented. You can then measure the effects of the change and act if things don't look right. So you might ask yourself, does this new version of code that's been deployed absorb more CPU than it did before? Is it causing a memory leak? Were logs configured in debug mode and now I'm starting to run out of disk space? I'm sure many of us can relate to having faced similar challenges or problems in our own environments. But hopefully by collecting data from your Linux host, we can make it easier to understand what's actually occurring in our environment. Then use that information to act in the best way possible to keep our environments running optimally. So next, we are going to cover the content included within the Splunk add-on for Unix and Linux. The content can be broken down into three categories. First, we'll look at the scripted inputs and files the TA collects. Then, we'll review the included knowledge objects like source types. And finally, we'll go over the configuration dashboard included with the TA. It's simply a tool to help you configure your inputs.conf file. So first, we'll do an overview of the scripted inputs and files. So what does the TA actually collect? You can have a look at the documentation on docs.splunk.com for more specific information. Here, you'll find a list of scripts utilized to collect data, like the performance statistics. So things like df.sh to pull disk information, cpu.sh to collect CPU statistics, top.sh to collect memory processes information, and bandwidth.sh to collect network statistics, and many, many more. Beyond performance statistics, the TA also can monitor the etc directories for changes to system configurations and the var log direct subdirectories for system-level logging. Given that the TA utilizes shell scripts and native Unix commands to collect data, It can be installed on a wide variety of Linux distros. However, not all Linux distros are created equal. We've also included a table on the release notes section of the TA highlighting the compatibility of each script on the most common Linux distros. So as an example, to collect a list of open files using the lsof script and command, bash is required. And the lsof command cannot be collected by default from the AIX and Solaris Linux distros. So finally, let's take a look at how the TA works and what's happening behind the scenes. So as I mentioned earlier, the TA collects performance statistics by running various shell scripts and built-in Unix commands you might already be familiar with. These scripts are executed by the Splunk forwarder and configured in your inputs.conf as a scripted input. The TA also sets up file monitor inputs for the etc and varlog directories. So at this point, I know some of you might be thinking, hey, typically access to those directories is privileged. That's right. That being said, it's important to check that the user configured to run the Splunk forwarder has permissions to execute the relevant Unix commands and read the output data. Otherwise, no data will be returned. All right, so that was a look at data inputs included in the Splunk add-on for Unix and Linux. Next, we'll take a look at the included knowledge objects, mainly focusing on the source types. So each data input included in the Splunk add-on for Unix and Linux comes with an accompanying source type. For more information on the names of the source types and their associated inputs, visit the Unix/Linux add-on section on docs.splunk.com. A majority of the included source types are SIM compliant, meaning it adheres to a respective Splunk Common Information Model data model, also documented on docs.splunk.com. SIM is a standard to normalize your data across multiple source types. It facilitates report generation, correlation searches, dashboards, etc., to give you a unified view of your entire data domain. All right, so that was a look at knowledge objects. Lastly, we'll cover the configuration dashboard included in the Splunk add-on for Unix and Linux. So as we discussed previously, the TA comes with a library of Unix shell scripts to collect performance statistics and input configurations to monitor changes in the etc directory and system logging in the varlog directory. But the data points you want to collect is up to you, the Splunk user and administrator. So the TA actually comes with a dashboard to assist in configuring your inputs. The dashboard has a button to enable and disable each file input or scripted input, and for the scripted inputs, it comes with an additional box to configure the interval of collection. Default values for scripted inputs represent a suggested collection interval by type. So as an example, CPU collection, by default, occurs once every 30 seconds, because changes in CPU can occur highly frequently. But for collecting changes in hardware, something that oftentimes changes slowly, if it changes at all, the hardware.sh script is configured to run just twice a day. In our next webinar, we'll discuss tuning the TA to best fit the needs of your own environment. So far, we've covered what can be collected and the mechanisms used to collect the data. Now we will cover where and how to deploy the TA. The TA can be safely installed on all tiers of your Splunk deployment. The TA ships with both search time knowledge objects, index time knowledge objects, and the set of inputs. When distributing the TA to host to collect data, make sure you've enabled the inputs that you wish to collect from in the inputs.conf file. The TA supports forwarders of any type and can be distributed to your forwarders either manually or via your deployment server. The TA should also be distributed to your search heads and indexers in order to take advantage of the index time and search time knowledge objects. Whether to enable inputs when distributing the TA to your indexers and search heads depends on your own data collection strategy for gathering data from your Splunk hosts. As an example, if you're running in Splunk Cloud, there's really no need to collect data from your cloud servers, as Splunk support is already monitoring those hosts. Next, we'll jump into a demo of the Splunk add-on for Unix and Linux and see it work in action.
First, we are going to cover downloading and installing the TA. For the sake of this demo, we will install the TA from within Splunk's App Manager. So to get there, once we're in Splunk, click from the App dropdown, Find More Apps. And then on the left-hand side, simply type the keyword Unix. And you'll see our first hit is the Splunk add-on for Unix and Linux. So I'm going to go ahead and click Install. Supply my splunk.com credentials, accept, and log in and install. Okay, great. So now the app is installed on my search head. And now let's go ahead and launch the Splunk add-on for Unix and Linux. So when I open the app, it's going to bring me to the configuration screen. So as we mentioned earlier, on the top here, you'll see the file and directory inputs. We have the etc directory for logging system configuration changes, and also the varlog directory for capturing system level logging. And below we have the scripted inputs. So these are the shell scripts that execute Unix commands to grab performance statistics. So it's important to call out here that any inputs we enable on this screen are going to be enabled local to this Splunk server. So as an example, if I were to enable cpu.sh and click save, we would start collecting CPU data from this particular search head. So I'm going to go ahead and enable a couple inputs. So let's go ahead and enable the etc directory, varlog, CPU, df for disk, top for process, and we're going to head and click save. And we're going to go ahead and just leave the intervals at default for now. And in our next webinar, we'll go over when and how to change those. So I want to take a moment and look at what's happening behind the scenes when we click that save button. So for those of you that are familiar with the Splunk app structure, what's actually going on behind the scenes is when we click save, the inputs.conf file is being copied from the default directory of the TA into the local directory, and the inputs that we've selected are going to become enabled. So let's take a look at that. I've gone into the file system of my server. See here I'm in the etc apps Splunk TA nix folder, and we have the default folder and the local folder. If we look in local inputs, and we can see that the etc directory is now disabled false, also known as enabled, and the varlog is enabled, CPU is enabled, df is enabled, top is somewhere in here, it's also enabled. There we go. Nice. Okay, so now that we've enabled our inputs, this TA is actually ready to be deployed to your forwarders. And so to do that, all you would have to do is copy this Splunk TA nix folder to the deployment apps section of your deployment server, or however you choose to deploy apps to your forwarders. Now, one thing you might have noticed when we were in the inputs.conf file is that there's no mention of the index where this data is going to be sent to. So if you've been using Splunk for a while, you might remember some of the older TAs had assigned an index destination in the index or inputs.conf file. But today at Splunk, we don't publish TAs with index destinations pre-configured, and that's in favor of letting you guys decide where to send your data. So that being said, If no index is configured, then the data will land in the default index, which is usually index equals main. Okay, good. So we've enabled our inputs, and we've seen how the configurations get enabled in the file system. So now we're ready to take a look at some data. So to start, we'll enter the search and reporting app and get brought to the Splunk search screen. And I mentioned that we'll be in the main index. Let me pull that up. And then we want to look at some CPU data. So to find CPU data in the docs, the CPU input source type is referenced as just CPU. So go ahead and we'll search that. And great. So here's some data. Right now, it looks like just the output of the shell script. But thanks to the Splunk add-on for Unix and Linux, it's added some field extracts to Splunk in order to make sense of this data. So to see what's actually included in here, we click this arrow, and now we see the fields that reference each of these data points. So all referring to what CPUs that we're looking at. This particular event is an aggregate, and the percent idle of the CPU, amount being used by the user, and the amount being used by the system. So let's go ahead and baseline this data. Take a look at CPU percent over the user over time. So I'm going to make a time chart, and I'm going to average the percent user, and we're just going to aggregate it every 5 minutes. And sure enough, here's our CPU data from the user side for the last 24 hours. You can see here I restarted my server, so the CPU was a little low and then it was getting up to speed as it was booting. And 60% utilization, I'm pretty comfortable with that. Earlier we talked about using this data to understand your resource utilization, especially as it pertains to virtualization. And this server being in the cloud, I'm pretty comfortable with it at 60%. It has room to spike if more process is required. And I'm not worried about overutilization or underutilization and wasting any money in the cloud. Awesome. So next, let's take a look at disk. So df.sh was the df source type. So we'll go ahead and search that. And same thing we saw before. So this is the output of the script running. And we go ahead and click on this arrow, and we can see the fields that are being extracted from this data. So 75G is 75 gigabytes available, 100G, 100 gigabytes total size of disk, and the usage percentage, we're at 26%. So let's also go ahead and trend this data. And actually, let's look at it over time for some more context. Awesome. So I started collecting data on June 4th, and we can see that each day data started to climb a bit, went down a little bit, started to climb again. And this must be because as I started to collect this data, the indexes started to fill up with data as well. So as I started to collect more Unix data on this server, started to fill up my indexers with more performance statistics data. So good. I'm happy with that. This looks like the server is performing as expected. Nice. So finally, let's take a look at the top data. So looking at process information as it pertains to CPU and memory. And now we are on the Splunk server. So let's take a look at how much of our system resources the Splunk user is taking up. So from a CPU perspective, I put together this search. So we're looking at top by user, the average CPU. So here's our Splunk user, and that makes sense that we're seeing more utilization from the Splunk user over any other user since this is a Splunk server. So that checks out, and looks like the Splunk process has plenty of CPU to run. We could probably even shrink the CPU maybe a little bit after analyzing it this way. Then next, let's look at memory. So I've gone ahead and put together this memory search. So similar to one we saw before, except instead of percent CPU, we're looking at percent memory, and we're searching just the Splunk user. This is memory over the last 7 days. You can see that looks like the server was rebooted around June 5th. Memory was sitting around 1% utilization, and over time, it looks like it's starting to climb a little bit. Restarted the server again, and it went down. So it looks like maybe a little bit of a memory leak. Maybe I've misconfigured a dashboard or save searches gone rogue or something like that. So something that I need to look into and understand why that's happening. So some further investigation on my part. So that covers it. The 3 performance statistics inputs we configured on this host. I hope that was helpful to understand how the Splunk add-on for Unix and Linux can be used to facilitate the data collection from your Unix hosts. The other inputs on that list are all pretty similar to these, and you can use the same strategies to explore that data as we saw here today. And ultimately, hopefully the knowledge that you've gained through this presentation can help you in your own environments keep your infrastructure running optimally. So with that, I'm going to turn it back over to Caitlin while I continue to investigate this memory leak on my side. So thanks everyone for letting me share some details with you today about the Splunk add-on for Unix and Linux, and I'll see you at the next webinar. Thanks.
Great. Thank you so much, Robert, for that informative presentation and demo. We're nearing the end of the talk, so I wanted to share a quick recap slide of the resources shared during the talk. You're welcome to screenshot these, though they'll also be available in a follow-up email, which will have the recorded webinar. Finally, don't forget that we have an incredible community of Splunk users on our community site, where there's a Q&A section, discussions, as well as Splunk ideas. If you wanted to learn more or continue the conversation, head on over there, and I'm sure you'll find what you're looking for. Well, we really appreciate you taking the time out of your day to join us today. Stay tuned for part 2, where we'll be doing a deeper dive into the TA. Great, thanks again. We'll see you soon.